Thanks very much, Stefan, and thank you for emphasizing the community aspect of this. We think that's really the reason we're doing it, is to bring people together. So we hope the activities today support that, and if you have things that you would like, bring those along to the town hall in the afternoon and let us know so we can discuss them. But now it's my great pleasure to introduce Shalini Kurapati today. She's the CEO of ClearboxAI, who are at the leading edge of making AI and machine learning accessible to businesses. They started in 2019, which is about 3 centuries ago in AI years. And they've been exploring questions of how to help people work with AI in responsible, private, and human-centered ways. It's great to have Shalini, because as well as working in innovation for Volvo and Hyundai, she has roots here in Delft. She did a PhD here in TBM with Alexander Verbeek and Heide Karen Lukosch. And we were just talking last night about having drinks in the nuclear reactor over the road. So we're very happy to welcome Shalini back to the stage in Delft to tell us about the future of responsible AI by design.
Thank you. So, good morning, everyone. I'm very excited to be here. Thank you so much, Phil and Dave, for this invitation, and really excited to be back in Delft. I've lived here for quite some time. So once we get that started, we will. Yes. So today, I'm going to be talking about responsible AI and by design. What I mean by design is how are we going to design and deploy AI systems that are responsible? So a little bit about me. I have lived in a lot of places in the past decade, and now I identify myself as an Indo-Piemontese. That's like the view from my house right now, where I live in Italy. And as my day job currently is actually to unlock AI projects, especially in the finance industry 4.0 and also in public administration. So how to deploy responsible AI projects in these domains, and I work in synthetic data. And we're going to talk about all these things during the talk, but to begin with today's discussion, AI is everywhere. Like, it was already there, but since the explosion of ChatGPT and the generative AI models earlier this year, everybody is talking about AI, although nobody agrees on a particular definition of what AI is, or in different domains, researchers debate about it, industry practitioners use it synonymously with so many other things. Even Excel could be AI, if you take it as a definition. So AI is everywhere. Now we cannot talk about innovation without talking about AI. But then we have to also see that there are a lot of utopian or euphoristic predictions about AI. It's going to add $15.7 trillion to the global economy by 2030. And more recently, generative AI, the ones that have seen an explosive growth earlier this year, apparently are going to add like 7% to the global GDP. So that means we are going to get lots of prosperity through these technologies economically. So many fields are going to be benefited. Societies are going to be benefited, apparently. At the same time, AI is a double-edged sword, and there are also quite a lot of dystopian predictions about what AI could do if we don't govern it properly. Like this is actually more the extreme kind of predictions by the Center for AI Safety, where they talk about if we don't build these systems properly, they could turn rogue. People could use it for malicious purposes, or there could be an AI arms race, and in the hands of bad people, things could go very bad. It's almost like we're talking about nuclear technology, coming back to, you could use it to light up homes, and you could also use it to blow up the world. So AI is this powerful technology, and when I talk about responsible AI, it's literally, we know that it has this potential, so how are we going to design and deploy these systems in a way that is safe, reliable, it doesn't intrude on your privacy, and it's fair and inclusive. So pretty much. And of course, even for responsible AI, there are a million frameworks for you to look for definitions. But in general, we're talking about embedding these principles already while we design and deploy AI systems. So now, like I said, we don't have a particular definition of AI that everybody understands. However, from an operational point of view, we can kind of not simplify, actually, make it more schematic to understand how do we start implementing these principles on what level on a technical side. So on a very general perspective, this is something people agree upon. AI is literally a powerful combination of data, code, and computational power, and whatever applications that come out of it, okay? So for majority of the AI applications we are seeing today, whether it's machine learning, deep learning, or the generative AI, the large language models we're talking about, they all need massive amounts of data for training. So all of them require data. Irrespective of the type of AI models you're using, data plays a very important role. And given that it's only a 25-minute keynote, I'm going to focus on data today, which is also my passion and specialization, because not only because I like it, it's because 80% of the time spent on building AI projects is spent on data. Collection, analyzing, cleaning, making it production ready, what we call. And if you think of a world-famous chef, making a nice plate of food for you, the ingredients are the data. So if you get bad ingredients, you get bad results, even if you are the world-famous chef, if you consider him or her as the model. Unfortunately, most of the emphasis right now is on the models, the bigger models, how many billion parameters there are, rather than on the side of how are we going to design our data pipelines to enable responsible AI. And in fact, if you look at the life cycle, generation, collection, processing, storage, management, analysis, visualization, all these things, if you look at it as a data life cycle, and 80% of the work is data work for AI. And one of the biggest reasons for failure of any AI project is the lack of availability of production quality data. Even though we see that there's the huge explosive nature of AI projects, if you look at companies in general, when they start building and testing AI projects and putting them in production, only 13 to 14% of them go into production. We have 85% failure rates of AI projects. Also, biggest reason being data. And some of the key problems for actually having, especially data for AI, I'm not talking about general data management, is that you need a lot of data. Because if you just have a few hundred rows of data, you can't build a machine learning. It's useless. Like you can have a simplistic model. And so scarcity, not everybody has access to these large amounts of data. And even if you do, they might not be balanced. They might be extremely imbalanced. And collection of data is quite expensive. If you want to have a robust data set that represents every single scenario that you're looking for to build your model, it's very expensive. And also, there are a lot of accessibility problems in terms of data privacy. Obviously, you need to respect data privacy laws, and also ethically, and IP and copyright issues. Now, here's where the futuristic aspect, or it's even current, comes in. And we are talking about how do we embed this. And there are many problems regarding accessibility. Let's start with copyright and data open ownership, especially when we are talking about AI. So some of the biggest issues at the moment, when you want to take the data and train your models, you need to be very sure that you're not infringing on both privacy, copyright, and you're making sure that there is a sufficient, you credit the owners, etc. And now I want you to, diverge slightly, because this is important for the context. This is the in terms of responsible AI by design, this is kind of the representation of the draft AI Act of the European Union, which the draft has been approved in June, and it will take a couple of years before it becomes law, but the draft has been approved. Basically, what the AI Act asks you to do is that you have to categorize your AI application into minimal risk, limited risk, high risk, and unacceptable risk. So basically, they give examples like spam filters in your email are also AI, by the way. AI is everything and nothing. And video games, for example, is minimal risk. So you just have to have a code of conduct, and you don't need to do anything much. However, if you have like chatbots or emotion recognition systems, they are limited risk, and you need to be more transparent about your procedures. And if it's high risk, that means if you're using AI for education or employment or immigration, you need to have very strict rules on model audits, data governance procedures. There's a conformity assessment. You kind of get a certification mark. It's still unclear who is going to give this certification. Auto-certification is also possible. So there's a lot of things to be discussed. And then there are things like unacceptable risk, like social scoring, which is prohibited. Interestingly, this was approved last autumn. Not approved. It was like almost ready last autumn. It was good to go. Then the foundation models came in. So the foundation models, what do I mean by foundation models? AI models that are designed for a variety of purposes. So in autumn, when they were talking about chatbots, they did not know that the chatbots could generate text or solve problems or create a website. So the application domain became so sparse that it was very hard to define what was high risk or low risk in the AI Act. So suddenly they started building upon a new set of rules for foundation models, which are the basis of the large language models, the generative AI. And then they came up with requirements of what you need for data, that you need to, you have to make sure that you describe your data sources. You need to make sure that you don't use copyrighted data. And you have to actually give a summary of what kind of data you used for training your models. And of course, there are transparency requirements regarding models and how you deploy them. So this was added in a couple of months. The other AI Act took a few years to come out, and this was added in a couple of months. And now, if you look at, and copyright is one of the, coming back to our aspect of copyright. So copyright is one of the requirements. And if you actually compare the current large language models, if they are actually following all these, firstly, ChatGPT, GPT-4 released a technical report about its inner functioning. Pretty much, this was the outcome of it. We used Python, was pretty much the most useful information we had. And Stanford did a kind of comparison, like with the current draft AI Act of the EU, if you look at the major large language models, they don't really perform very well. They are like not even half. Hugging Face is the blue model of Hugging Face does OK. And if you look at copyrighted data, almost none of them are able to show whether they are able. They are not able to declare their data sources, whether they have infringed copyright or not. And this is a big problem, especially for people who create, and also to have the difference between AI-generated content and human content and the creative rights and IP rights. And this led to a lot of issues, and most interesting one is, maybe you've heard about the lawsuit of Getty Images against OpenAI, because the AI-generated images even had the watermark of Getty Images. So it was basically, it was a big fail. But so that means that they're scraping everything that's available out there and training their models. And how are we going to deal with this? Because it's not just a legal problem, it's also an ethical problem, right? Crediting the right people and giving them the right compensation, etc. And now things are slightly changing. For example, Shutterstock, which is another stock image platform, has partnered with OpenAI for 6 years, and so they are buying a license. So now they are doing something about it. But how do we make sure that the data that is used for AI models are respecting these laws? And it's all not bad news, because now there are methods to actually add credentials and also metadata that can help AI models to understand what the data sources are. For instance, Adobe has a very good example. They are part of this content authenticity initiative. What they do is they have a kind of an audit trail for a particular image. So what has happened in its life. So it has been taken by somebody, and it was processed by Photoshop. So you can even have a slider to see the difference. And there is a lot of attribution of who took it, when was it, location, person. So these kind of machine-readable credentials are extremely important, and they need to be tamper-proof, of course. And this also has been applied to generative AI. And it's important that we have these credentials both for input data and also the output data. So we know whether we are using the right data, and also when we produce the data, whether it's AI-generated or human-generated. It's extremely important. The same thing, if you look at it, it's good to know that this content was generated with an AI tool. So you have a kind of an audit trail. And at the same time, even metadata is extremely important. And there's a good example also there. Like, for instance, Google has introduced an IPTC standard where it embeds metadata information in images, whether it's trained on synthetic data, or is it a composite synthetic, or it's fully synthetic. So this is extremely important. And I'm not going to touch about text, because images are easier to have a track. Text is very difficult to have an audit trail and to actually detect whether it was AI generated or not. There are some new technologies such as watermarking, but we are still not there yet for text, unfortunately. That's also a research domain, also maybe for these young researchers to think about how do we think of putting credentials in text to know whether it was AI generated or not, because the current tools don't work really well. So images are okay. And then, so we talked about copyright. And the next part is about the quality of the data itself. So when we talk about quantity, obviously AI models require massive amounts of data. At the same time, the quality is so important, because it's literally garbage in and garbage out. And there are many data quality problems with respect to AI, but one of it, of course, we don't, sorry, this is coming out. Yeah. One of it is data labeling. So humans actually, there are also human tools or also automated tools that can label data. So you literally have to teach the AI whether it's a dog or a cat, or whether a text is like a review on Amazon is positive or negative, or if it's an audio file, what's inside an audio. And you need to, and you might see the boxes, right? So somebody actually literally puts the box around it to understand what's inside that aspect. So this data labeling is extremely important for many kinds of AI. And here, there could be so many errors in labels. So here, we're talking about ImageNet, which is one of the most common library of images. And that's the Doodle data set of Google, Quick Draw. Actually, it's a fun game if you want to try it out. And all of them have, they're completely wrong. So a human can immediately say these are a pair of jeans, these are two children, it's not a patio, it's not a baseball bat, and that review is actually positive. So these kind of, when you go into the AI models, they make a lot of mistakes. So we have accuracy problems when it comes to data. And we have to also remember that despite the fact that they're saying that humans are being replaced, even AI, for the current AI tools, humans are very much in the loop. So this is, so my colleague tried to ask about, I want to build an explosive device, and it says, no, you can't, it's not allowed. And at the same time, when he asked, I would like to replace a defective electric outlet, it gives me the instructions. This is ChatGPT-4 and GPT-4. And this happened, it didn't happen automatically. Maybe a few iterations ago, they would have given me the examples, or my colleague the examples of how to build a bomb. But actually, what's happening is actually humans are teaching that this is unsafe and you should not be giving it. So there is always this human component involved, and that also means that there's a lot of human cost involved. There are like people, there are data farms in many countries where they're literally looking at all the content of these algorithms and trying to say, is this good, not good, this is safe, unsafe, and the human cost of this is also massive in terms of ethics. So we have to keep that in mind. And the other big problem is the imbalances in data. Because, like I said, quantity is not enough. You also need a representation and a balance of data sets. We can start just simply by looking at if you are, I'll give you, I'm going to go by examples today. If you're building an algorithm to detect anomalies or frauds, right? If you're a bank and you want to make sure that your transactions are fraudulent or not, because you have millions of transactions every day, and you need an algorithm to say if somebody is making a mistake or doing something illegal. Unfortunately, or fortunately, the number of frauds compared to the number of normal transactions are very few. So that means the algorithm doesn't have enough examples of frauds to learn. It has normal transactions, so it can recognize the normal transactions very well, but the ones that are fraudulent, not so much. And here, the accuracy is very low because you'll have so many false positives, and that's not good because, again, you just need to give lots of data to these algorithms. The more you give, the better they are. So if you have very imbalanced data sets, they don't work very well either. And then the other major issues we still don't have a proper solution is the issue of bias, because we don't have data sets that are representative. Most data sets that we use are 80% lighter skin, 75% male faces on average. And when you're going to train these algorithms, they just don't know whether it's ethical or not ethical or representative or not. And the kind of outputs we get are also very telling. Like if you ask, I haven't run this test with the latest version of DALL-E, but when you ask a CEO, you have a white man, a Western white man. And then if you ask for a nurse, it's always an Asian kind of looking a woman all the time. And even textually, when I try to ask a question about the doctor yelled at the nurse but because she was late, who was late, and the same question when I switch it, with a he or a she, it always assumes that the he is the doctor and the she is the nurse, anytime I do it. So that's... And it becomes even more distressing because this is, okay, we can say this is bias, we need to work on it. And sometimes it's distortion of reality because stable diffusion, which is another tool to produce images, when you ask them to produce images of an architect, lawyer, politician, doctor, it's very, very heavily male-centric. So the percentage of images that come out are very, it's usually a man, which is not even the reality because in Italy and Netherlands, 50% of women are doctors. And the number of doctors that are shown in the, that are being produced do not even represent the reality. Also judges, like there's a very big number of female judges. And we don't have this data. Somehow it's missing in the pipeline. So what's happening? So these are the kind of things we need to be thinking about. How do we design this to close this gap? So some of the questions, so these are a lot of things. I threw a lot of problems at you. So let me also think of how do we start thinking about the solutions. Is that when we, let's begin by answering these questions. So where does your data come from? And who is responsible for the different parts of your data pipeline? And how do you design your data pipeline? And the other question is, what information is included in the data? What is the metadata? What are the credentials? And is this fit for purpose? Is this enough for my algorithm? Or do I need more? Or do I need more test data sets? And how much is enough? And there is no standard answer for that. And that's where also you need to have these discussions. And who and what is covered in the data? And if there are any underrepresentations or even overrepresentations, you need to be having to think about that. And are there any missing informations or some units are partially covered? So these are the things that you can, these are the more operational things you can start thinking about. And in terms of technology strategies, there are many ways to deal with the data quality issues. There are automated error handling, fixing imbalances with data augmentation. I'm going to talk about that with synthetic data very briefly. Active learning, and how do we embed privacy and ethics by design in your data pipelines? How are you going to build it there? So how this could look in practice is that, for instance, I work in synthetic data, for instance. I can give you one use case of how data-centric AI can be utilized to reduce imbalances and promote privacy. So for instance, I work in synthetic data. It's actually fictitious data that is using a group of generative models. We create synthetic data that represents real-world data, and either for privacy preservation or data quality augmentation. And Gartner predicts that, Gartner, the market research organization, that in the next, in this decade, synthetic data is going to overtake real data to train AI models for the reasons I just spoke about. Main reasons that you could use a technology like synthetic data, it's not the only one, is to reduce the data scarcity if you don't have enough data to start with. If you have imbalances in your data set, you can augment the examples. And also, you can mitigate data by providing more examples with different skin colors, for example, or different populations, for example. And again, and in terms of privacy, it's great to share data because you don't have one-to-one identification, either for cloud migration or software testing or performance migration. And especially GDPR and European Data Protection Supervisor consider synthetic data to be a privacy-enhancing mechanism, and also AI Act mentions specifically of the use of synthetic data for AI models. And for instance, we work with banking and industry partners on these use cases like data sharing, data quality augmentations, and even bias mitigation in this. And what we look, how could it look in practice is that we have an element of data quality where it requires data profiling and preparation to see if the data is good enough or fit for purpose. And then when we generate the data, we look at how private it is, how balanced it is, and how useful it is for different applications. So technology alone is not enough because oh, sorry, I have to go back. Technology alone is not enough, but it has to be backed by strategy because you have to really, you cannot just say AI is somebody with the technology side. No, because you need to have a clear business purpose or a research question, and then you need to kind of map it with the technology and skills, of course, what is required, what are the technologies I can use, how am I going to embed quality and ethics, and how am I going to ensure privacy and security, and what is the impact on innovation. You need to have all this in place. So with that, I would like to thank you and leave you with this, that in God we trust, all others must bring data. Thank you.
Have a few minutes for questions. I'm going to see if there's a burning question from the audience. We don't have very long, so if someone puts their hand up, they can jump in before me. Wonderful.
Thank you so much for your presentation. For me, it's all quite new, however inspiring. One question that came up for me was, right now, humans are still very much involved in ensuring that the data is being morally categorized in the right way. Do you expect that to remain as such, or will humans be needed less because the algorithm also learns how to distinguish right from wrong? Mm-hmm. I don't know. What do you think?
Yeah, that's a very good question. As of today, I cannot, in future, we don't know, but as of today, this is still the norm, even with OpenAI and others. It's called reinforcement learning with human feedback. That's the one that is working the best in all models at the moment. It's the only problem is that there's the human cost and it's not scalable enough. And there is also the other thing that there have been some studies where if it's only generated by AI, the model performance also goes down because they're just generating from AI-generated text. Like if you start training the models without any human input and it's just learning from its own outputs, the model performance is degrading. So for now, looks like humans are very much needed in some aspect or the other as of today.
Okay, thank you so much.
Any more? We have time for about one more. if there's no hands up, I'm going to ask. So for half of that talk, you were opening up this wonderful space of all the ways things can go a little bit wrong. And I was going, yes, fantastic, but what do we do? And then at the end, we had the answer, synthetic data. So does synthetic data save us?
No, actually, I don't believe in one solution that's going to save it all. I was focusing on the data element of it. And for data, synthetic data could be a great ally because it's one of the technologies, of course. Like you also need to add it with other technologies like federated learning or homomorphic encryption. But what we are trying to look at is where does it come in? Like for instance, especially in your data acquisition and quality control, it could help you a lot by understanding what data do I need. If I would need a variety of data sets, can I generate it and test it? So you could think synthetic data as kind of a test bench. Think of it, you have a new car. Before it goes into the market, you want to test it on ice, in muddy roads. And you can think of these roads as data sets. Like, can I test my model in all kinds of situations? And that's where it could help. So it's of course, one part of the solution. I'm not saying it's going to solve the world, but it's definitely, when you're talking about data-centric AI, you cannot talk about it without synthetic data. Yeah. Thank you.
How are we on time? Do we need to? Yes. OK, so thank you very much, Shalini. And I'll hand over to Phil.
Thank you.